what if buried within the genes of an humble sparrow, there is a simple mechanism that could hold the key to spend better time and more time with our loved ones? Today, I'm going to talk about sleep. We all know what sleeps look like. We spend a third of our life asleep. You lay horizontal, you are relaxed, and you are unconscious. But you are not in a coma, and you are not dead. So if the baby next door starts crying, I'm sure everyone in this room will briskly stand up and give him a cuddle. So let's not wake him up, right? A more relevant question is, why do we sleep? And we don't really know. There are several theories. Perhaps we sleep to store and retrieve memories. Perhaps we sleep because we need to, because of our the energy consumption of the brain. But as a matter of fact, we don't really know. What we do know is that prolonged sleep deprivation is fatal. We have to sleep. It's a need. And the second thing that we know is that because we don't know what sleep really is for, our interventions, our current interventions are really ineffective. This is a graph showing the risks of death while you're taking currently available sleeping drugs. And as you can see, just having 18 sleep pills a year, which means 1.5 sleep pill a month, triplicates your chances of dying. So probably is not a very effective treatment to harvest the benefit of sleep. But let's have a closer look to what sleep is and what drives sleep. Let's say sleep is driven by two mechanisms. One is called the homeostatic drive. So what it means is that the more you are awake, the more sleep pressure during the day increases, so the more you feel the urge to go to sleep. This is what really sleep need is. You can think about it a little bit like the battery in your phones. You know, at some point it will end up and you have to recharge it. If you could have a battery that lasts 3 weeks, probably it would be a good thing, because, like, you know, as it was in the 90s, actually, I was saying. But there is another component to sleep that it's much easier to understand, and this is the circadian rhythm. So why is it easy to understand? We are all familiar with the fact that we are constantly exposed to light and dark cycles, which are determined to the Earth spinning on its axis. And what this means, this determines, is that there are a lot of changes in our environment. So soon enough in evolution, we have developed mechanisms to anticipate these changes, so that we can make a treasure of the opportunities that predicting these environmental regular changes carries. The irony of the present day is that we use the circadian clock to actually disrupt our sleep patterns. So this is clearly not an ideal situation. But let me tell you a little bit more about how the circadian rhythms work. They work because there are a handful of genes called clock genes, specialized genes, which oscillates within our cells, and they oscillate with a rhythm that is approximately 24 hours circadian. What is interesting is that very early in evolution, they have been developed. It's a very fundamental mechanism. Bacteria in the wild, they have it. Plants have it, and we have it too. But what happens is that as complexity increases, the number of pathways and mechanisms that are controlled by the clock increases too. And in our close relatives, other primates, up to 82% of the genome, it's rhythmic. And this is determined by a handful of genes. But why do we observe this increase in the number of pathways that are dependent on the clock? Well, that's quite easy to understand, because, of course, we are not bacteria. We do a lot more things during our day, which is not just sleep, but, you know, we have to get the kids to school. Our blood pressure, for example, our hormones have to change on a daily schedule so that we always meet the requirement of the performances that we need to perform to basically be adapted to the external world. So if the clock is the oscillators, the brain is the orchestra, and it's a very complex orchestra. Let's move on. If this is a very important mechanism, what happens if you destroy it? And you destroy it a lot of you probably, they go on planes and are very familiar with the experience of jet lag. This is probably the only time in which you can really feel it very strongly that you have a clock, because your clock cannot adapt so quickly to a new time zone. However, what is more relevant to health is probably the chronic status of disruption that we have to experience because of our lifestyle. Not only we have low light levels during office hours, we also sometimes do shift working, or we just like to party. So all of this, for a long time, may have very grave health consequences. And in fact, they do, because sleep and circadian disturbances are associated with chronic diseases that are very relevant, like obesity, cardiovascular diseases, diabetes, and dementia. And I am, as a neuroscientist, I'm personally really interested in dementia and in the brain. And why is that? So dementia is an ongoing epidemic. There is no cure for dementia. It's due to the accumulation of toxic protein in the brain that will eventually kill the neurons in your brain. So what is the problem with dementia? And as you can see, first of all, this is an epidemic that is not going to stop because we don't have treatment at the moment. And this will be particularly relevant in Western world, but also even more so in fast-developing countries. But what's the problem with dementia? The problem is that it's a catch-22 situation. By the time people see the doctor, they already have the symptoms. And by the time they've lost their memories, the neurons are already gone. So what you will really want to do is to spot these processes early enough. And this could be possible because actually the developing of dementia takes decades. But let's assume that you could do that. What are you going to do then next? So are you going to tell the patients, look, you may develop in 10, 15 years, you may develop dementia, but we're going to tamper with your neurons right now. And if you are lucky, and if you are lucky too, we may sort you out for the next 10 years. So this is not gonna be easy. So Imperial College is at the forefront of a wider national initiative, the UK Dementia Research Institute, which wants to find new ways of tackling dementia. But what is about sleep and dementia? What's the connection? Well, it turns out, if you read the latest news, that very early on in the disease, when people don't have any cognitive dysfunction, they already show very important signs of sleep and circadian disruptions that you can measure. And it turns out that the proteins which are involved in dementia also show a daily oscillation. And even more importantly, prolonged bad sleep increases the concentration of this toxic protein in the brain. So this is a big deal because 99%, for example, of Alzheimer's disease, which is the most prevalent form of dementia, is not directly linked to the genes. There is a predisposition, but it's probably the consequence of our exposure to the environment and our lifestyle. So what if sleep plays, and our disruption of sleep plays a big role in the triggering of the dementia processes? So my lab focuses on the idea that what if we harness the clock, we exploit the clock soon enough during the disease development to actually prevent or delay the onset of dementia. So what the problem is, we are not going to convince people for us to tamper with their neurons. So the idea is let's not touch the neurons, because neurons are a minority in the brain. 80% of the cells of the brain are not neurons, but they are cells that are associated with neurons, and we don't know a lot about them. So what if we can reprogram the neurons to perform their function without touching them? So without touching these very special cells that are unique. So this is what I did, this is what we do, and I'm just going to show you some real data. So in preclinical models, in mice, we can actually look at the expression of these clock genes in the brain in real time. Every dot here is a cell in a specialized area of the brain, which is the most important one for circadian rhythms. And as you can see, a normal mouse has a strong oscillation. As a consequence, this mouse sleeps well, and it has normal, regular sleep patterns. We also have mice in which this clock is destroyed, and this is what I'm going to show you here. As you can see, there is no oscillation. As a consequence, the mouse is not happy at all, doesn't sleep at regular time. It has very serious cognitive deficits. But as this movie plays, what we will be able to see is that, and this is playing again now, what I did was to target just a few cells in these brain areas by gene therapy of cells that are not neurons, but that are associated with neurons. And even just a handful of these cells targeted restore the circadian oscillation in the brain. So what have we done here is to reprogram the circadian activity of the neurons without touching them. So I think this could be an extremely exciting strategy that could be employed and deployed to prevent potentially the sleep disruption and potentially dementia. But, of course, I will be very happy if we manage to cure dementia this way. But I just want to make the point that the influence of circadian rhythms and the awareness about circadian rhythms is going to have much wider societal implications. Not only about health, of course, therapy is a big thing for me, and therapy of other chronic diseases. But think about this. Your sleep patterns could be easily identified by your watch, your iWatch, for example, and by sending data to the cloud, patterns, and if we all do this, artificial intelligence could detect altered patterns and tell you if you are at risk and you should see the doctor. For example, there is more to this. There is well-being. There is a lot of pressure of nutrition, currently a lot of attention about nutrition, your 5 days, and so on. But we should really implement the idea that we should sleep 7 hours a day. There are companies already in the States that are giving bonus prizes if you sleep well, because basically, if you don't sleep well, you're not going to be productive. And this is the last point, productivity. We know that all of us have a different chronotype. So there are people that like more to work and perform better in the morning. There are people that perform better in the evening. But our society currently is only organized to suit one type effectively. Whereas we should probably design our teams and the interaction that we have also considering when these people can work better. It's interesting that the chronotype is a mechanism that originated for the tribes to protect us from our need to sleep. So because if people can sleep at different times, the other people will be able to protect the tribe. But in time, this has been completely lost. So I think this is what is going to happen in the next 10 years. But what is going to happen later on? What is going to happen in the next 20 years? So let's go back to our humble sparrow. So why the sparrow? So the sparrow this is a white-crowned sparrow, and it's interesting because it's a migratory bird. It goes to a remarkable journey of 4,000 miles. And what it does is that it doesn't sleep or it sleeps very, very, very little during this trip. And what happens is that it doesn't suffer from lack of sleep. And the reason why it does not suffer from the lack of sleep is because somehow, and we don't know yet how, it managed to slow down its circadian clock so that the circadian clock that it has manages to protect him from the lack of sleep. It does not have to compensate for this after, and it's protected. It's absolutely fine. So what I believe is going to happen is that we are going to find out more and more ways to manipulate our clock to potentially control our sleep demand online. And I think this will enhance our performances, and it's up to us. Perhaps we will be more productive. We may be able to sleep better, or just we may be able to spend more time with the people that we love without having to sleep all the time. Thank you very much.
Thank you, Marco, for a very interesting introduction to the subject. So we have some of your questions.
A very interesting question.
Well, is there one you would like to answer first rather than me picking for you?
Thanks, I get to pick.
Why not?
Well, I think this is like, can gene therapy in old age make up for bad sleep pattern earlier in life? I don't think so. I think by the time you have already symptoms in the old age, it will be too late. The answer is not necessarily gene therapy in humans, in patients in early stage. But what we could do is to make drugs that target not the neurons, but the astrocytes. So although, of course, in a preclinical model, it's easier to do gene therapy, that may not be the only options to sort this.
So I'm going to suggest we go to the top one, because I can see that it's had 4 upvotes.
Yes.
So a lot of people want this question answered. And what are the main lessons businesses and industry should take from your work?
Oh, well, I think the message here is that circadian rhythms give an opportunity. And the opportunity is to design your production processes in a more efficient way by respecting what is the internal clock of different people. So there is no reason why you should go against the clock, because at the end of the day, if you force an owl, so a person that will like to work late, work in very early hour, it's just not gonna be productive.
So yeah, we can move to the next one. What do you do as a neuroscientist to combat misaligned circadian rhythms?
Yeah, well, my work is about changing the brain in different regions and trying to understand, which regions are from a circadian standpoint, which regions are more important for some specific aspect of circadian rhythms. For example, if we want to be better performing at cognition, so which is the best region to target? Is it the cortex, or is it other related other related areas?
So I think
should we avoid? This is a good one. Now I'm going to scare you. There has been research on flight attendants that are, on long-haul flights frequently. And what it has been shown is something that is really concerning. So these people show evidence of cognitive dysfunction well after they have been exposed to discontinuous jet lag, so for more than 10 years. So the effects of, constantly going in on transatlantic flight may have long-lasting consequences that are not fixed really in the short term.
Maybe the second question from Claude, why is this research happening now? What's enabling you to do your work at this point in our human development?
Yes, I think now it's a very exciting time for neuroscience, because the study of the brain, because of the complexity of the subject, of the object of study, actually, it's been lagging after our slides. But now other research. But now we have very, very specialized tools to actually really select single cell in the brain, manipulate them online. And as a neuroscientist, I think we will only be able to understand the brain once we really understand how to manipulate it to change our behavior. And this is something that just wasn't possible 10 years ago.
And so it looks like the next question is related to your sparrow vision, that if gene therapy could reduce the amount of time we need to sleep, is this possible, and would this be a good thing for us?
That is a very, very, very interesting question. I think people will feel differently about this. So to me, sleep definitely has benefits. I don't know, I don't feel that being cut off from the world for a third of my life is a particularly exciting experience. So I would say if I could spend that time, but still having the benefits of sleep, I think that would be a good outcome. But I'm aware that a lot of people do love to sleep. So, this may not be the answer for everyone, but perhaps this is one of the messages of this talk. Your tendency and your circadian and sleep tendency should matter, and should matter to society as well. Teenagers, they have very hard time because their clock is shifted towards a late phenotype. And this is biological. It's not because they don't want to wake up in the morning. But that's exactly what happens, that the parents trying to put pressure on them to go to school because the school opens early. And this is very unfair. And it's only recently that trials in UK are ongoing to shift the time at which schools open. And it has been already shown, and data are really promising, that these kids perform much better. So, is it the need of the kid, or is it our need to go to work, early, and the societal need that is at stake here?
Great. It looks like we've had a firm favorite question rising the ranks as you were giving that answer, right at the top there. Which is more important, depth of sleep, regularity, or length?
This is another. So all of them. The length. Length is what is there is an absolute length. So in UK, 70% of people have bad sleep. A quarter of people sleep less than 5 hours a night, and that is definitely detrimental. But you don't have to have necessarily 8 hours a night. 7 might be sufficient. So there is variability. There is not a single answer. Of course, the pattern and the depth of sleep is really important, because the deepest sleep is the one that seems to be more important to restore your function of the brain, in the brain. So, and that is something that you can actually have already a look with your iPhones or with your watch. I mean, there is a lot available already that technology can do for us to understand how do we sleep, because we actually don't know because we are asleep.
And so is it possible to oversleep? Can you sleep too much?
Yeah, yes, of course you can oversleep. There are conditions, narcolepsy, that makes you oversleep, and it's not good life either. Like, you need to sleep the right amount. That's the message.
Mm-hmm. So the next question seemed to be about our circadian rhythms. Is there anything else other than dementia or detrimental effects to the brain? Do these affect any other parts of our lives?
Yes, well, the importance of circadian rhythms is pervasive. As I mentioned, diabetes, obesity. What it has been shown, this is a very interesting research. There are people that eat all around the clock, right? And this is a very common pattern, especially in the US, but also in the UK. Now, the study has shown that regardless the quantity of food that you eat, the calories that you eat, if you have such a pattern of behavior, you will gain weight, even though you don't overeat, because our bodies is not suited to continuous eating. Our clock is not efficient at every point of the day to allow us burning through these calories. So yes, there is a lot that is affected by the clocks, not just sleep.
Okay. A new favorite, does the blue light filter on smartphone actually help?
Well, there is a scientific foundation to this, because our internal clock are particularly influenced by the blue wavelength of the light, and that is why you should always try to get sunlight in the morning. What happens is that if you have an intense blue light, and our screen, laptop, iPad screen, are particularly strong on blue light without filters, you will trick your body, if you do this at night rather than in the morning, to think that it's morning. So your clock, your internal clock will shift, and you will sleep. You will basically tend to be asleep later. So you will disrupt your sleep pattern. So it's definitely a good idea not to be exposed to high artificial light in the evening. And I think having filters of blue light, it makes sense, basically.
It looks like we have a few seconds left to answer the last question. There's some evidence that sleep trackers cause anxiety, meaning that people can see they're not sleeping enough. What's your view on this psychological impact?
Well, it's a bit like blood pressure. If you see your blood pressure, you probably that will rise too. So perhaps, yeah. Well, ideally, you may want to not be able to see them, but you may want to have them transferred so that you cannot see them online, but download them later on. That would be a way to go about it. It's a good question. I think I know who it's coming from.
I'm afraid that's all we've got time for. Marco, thank you so much.
Thank you.